In this video, we're going to look at the chain rule. Now, the chain rule is when we have something like this. You can see it nearly looks like a part of a chain on a bike. So rather than one thing just to be squared, like 3x to be squared is not the chain rule, but 3x plus 1 to be squared would be the chain rule. So let's have a look at this. The rule is very simple. So we take the power, we multiply it by the front, so we're going to get 3 by 3x plus 1, and then we multiply by the derivative of the bracket, so we just differentiate what's inside there, and we're going to get another 3. So the answer to this one is 9 times 3x plus 1. Sorry, I should have said reduce the power by 1 to be squared. Now, you could multiply this bracket out 3 times, and then differentiate it, but this is a much quicker way of doing it. So we consider this function f of x equal to the square root of x squared plus 5x minus 2. The same rules apply. So let's write it to a power first, x squared plus 5x minus 2 to the power of a half. So we take the half, the same rules up here with the 3, multiply by what's in front, and obviously I forgot to say reduce the power by 1 the last time, so let's do that. A half by x squared plus 5x minus 2 to the power of minus a half, and then we have to differentiate the bracket or what's inside. Sometimes this is known as the inside-outside rule. So we differentiate by that x squared plus 5x minus 2, and we're going to get 2x plus 5. So similar to what we saw in the last video, this whole thing to the power of minus a half, I'll keep the half separate, is 1 over the whole thing to a positive power. So it's going to be to the power of a half, which we can write as a square root, x squared plus 5x minus 2. 5x minus 2. And then on top, the 2x plus 5 stays there. So the answer to this, f prime x, is equal to the only thing we have on top is the 2x plus 5. And what do we have on the bottom? We have twice the square root of x squared plus 5x minus 2. And I would recommend you learn this way of using the chain rule. It just makes it so much easier than the kind of inside-outside functions and letting one equal v and letting one equal u. I think when you learn the method in any type of maths, it just becomes easier. So try these 3 now. And here's the solution. dy dx is equal to 3 times 5x squared plus 1 to the power of 2 multiplied by the differentiated bracket, which is 10x. So tidying it up, we're going to get 30x times 5x squared plus 1 to be squared. Next one, dy dx is equal to 3 times x squared plus 7 to the power of 2, and we're going to multiply by the differentiated bracket, which is 2x, and tidying this one up, we get 6x by x squared plus 7 to be squared. And this one, dy dx, is equal to 4 times 3x cubed minus 8x to the power of 3, and we multiply by the differentiated bracket, which is 9x squared minus 8. 9x squared minus 8. Now, because there's 2 parts to it, we need to multiply the 4 by both of these. So it's equal to 36x squared minus 32 times 3x cubed minus 8x to the power of 3. So your basic chain rule knowledge. So try these 3 next. dy dx is equal to a half times x squared plus 2x to the power of minus a half, and we're going to multiply by 2x plus 2. So again, apologies if you can hear the dog snoring in the background. We're going to get, this is the only one that's going to stay on top. So we have 2x plus 2 on top. And at the bottom we have this 2 by this guy to the power of a half, positive a half, or the square root of x squared plus 2x. dy dx for the second one is equal to, I'm going to write it as x squared minus 9 to the power of a half first. So it's going to be a half times x squared minus 9 to the power of minus a half, and we're going to multiply the differentiated inside, which is just going to be 2x. So you can see here, the 2x is the only thing that remains on top. And on the bottom I have this 2 twice x squared minus 9 to the power of a half, or the square root of x squared minus 9. The third one we can rewrite as x squared plus 7x to the power of a quarter. So we're going to have dy dx is going to be a quarter times x squared plus 7x to the power of, we're reducing the quarter by 1 to get minus 3/4, and then we're going to multiply by the differentiated inside, so we're going to get 2x plus 7. Again, this 2x plus 7 is all that remains on top. On the bottom we have this 4, and we're going to have the square root of x squared plus 7x, and it's a fractional power, so the top goes in here, the 3 and the 4 goes in here.